Okay. And what's the vertex angle of an isosceles triangle?
What do you mean?
Well, let's say that you didn't know the definition of that.
Oh, yeah.
What would the answer be, regardless of whether you knew the definition of that? First of all, what's an isosceles triangle?
It has two equal sides.
Well, which side, if they said the vertex is one of those corners, which one would it be?
The one in between the two even sides.
Yeah. In other words, if they're talking about the vertex as being a single thing, the only thing unique is B. That's got to be the vertex. It can't be A because A has the same thing as C. So even if you didn't know the definition of vertex, you'd be able to figure it out. What's the relationship between the base angles? The base angles are the angles opposite. In other words, the angle opposite that side is C. What's the angle opposite that side?
A.
And what's the relationship between A and C?
They're equal.
Yeah. And that you will find when they test you on isosceles triangles, that that's the thing you need to know more than anything else. Because it's too simple to just say, okay, if this side here is 8, what is this side here? So they want to make sure you know that the two angles are equal also. All right, let's look at this figure over here.
Oh, yeah.
And these 4 questions apply to this figure.
Okay.
So if AE is equal to DE, then which two angles are equal? Or I say equal, I mean congruent.
Angle EAB and EDC.
Okay, that's fine. You could actually label those angle A and angle D. In other words, you only need to use 3 letters if it's necessary to use 3 letters. You know what I'm saying?
Yeah.
Certainly EAB is the same as angle A. But if I say angle A, there's no other angle here that could fit that description, so we know that it's that angle. So
Okay.
my response here would just be angle A and angle D. Okay? If AB is congruent, AB is this piece, and it's congruent to EB, then which two angles are congruent?
If AB, wait, what? Sorry.
Yeah, that's okay. Here, I'm going to draw it because it'll be easier for you to see if I do. So, if there's AE,
Okay.
excuse me, hold on, I did that wrong. That is E, but here's the one they're saying is congruent. That's AB. They're saying that is congruent with BE. In other words, this is equal to that.
Okay.
So which angles are equal?
Angle A and E.
Okay, now in this case, you can't define this angle as angle E. I mean, you can as long as you're only looking at this triangle. But if we're looking at this figure up here, how do you have to define that angle there?
AEB.
Correct, or BEA even. But this is a case where you cannot define that angle with a single letter, because angle E would actually consist of that entire, all 3 of those angles. Okay. So the only time you can use one letter is when it's non-ambiguous. In other words, when I say angle A, there's only one angle in this picture that fits angle A or angle D. But every other angle, I'm going to need three letters to define. So I would say angle A is equal to angle AEB. Okay?
Okay.
In other words,
Yeah.
that angle is equal to that angle. This angle right here is equal to that angle because they're the opposite angles of those triangles. Number 5, if angle D is equal to angle CED, in other words, that's equal to that, then what is congruent to what? Notice they don't put an angle. In the two previous problems, they suffixed it with an angle. They don't here.
The two angles that are congruent are D and CED.
Correct.
Or, well, it already says that.
So what does that mean?
Angle CD and CE are congruent.
Not angle, but line segment.
Yeah. Yeah.
Yes, you're correct. EC, line segment EC, is congruent to line segment CD. Okay? And that's the little tip they give you because they don't put the angle in front of it. Surprised they don't put the line over the top and leave it in. Okay, if angle EBC, this one right here, is congruent to ECB, this one right here, then what?
Then line EB and EC are congruent.
Okay. Find the unknown measure.
For 7?
Uh-huh.
Oh, that's just 12.
Okay. All three sides are 12, right?
Yeah.
Because when you have three angles that are all equal, they have to be 60. And that makes it an equilateral triangle, and an equilateral triangle has three sides that are the same.
Yep.
About 8.
Well, isn't that just 16 again?
Uh-huh. For the same reason. That is an equilateral triangle. In other words, if you have two 60s, that has to be 60. That makes it the situation here. And 9?
The question mark is 60 degrees.
All right. If the base angle, I better draw my picture just a little bit better. When they say the base angle is 37 degrees, which one do they mean?
Do they mean both of them?
Yeah. In other words, they mean A and C. Okay. So they're saying that's 37 degrees. Draw and label the triangle. What's the measure of the vertex angle? In other words, once again, as long as you know that that's the vertex angle, the only thing that could be the base angle is one of these two. So this is one of those definitions that you don't really need to memorize because you can always figure it out.
Is B 106 degrees then?
Well, let's see. That's 37, 74, 106 is correct. Okay.
Awesome.
Number 11. They want to beat this problem to death, huh?
Yeah.
Which is surprising because I've seen isosceles triangles beaten to death, but you rarely see equilateral triangles beaten to death. They just don't come up that often. I mean, they're not a common problem. When you go to take your ACT test, you'll be lucky if you see one problem based on equilateral triangles, where you'll see 4 or 5 based on isosceles triangles. About 11. What kind of triangle is that?
That's equilateral.
What does that mean about all the angles?
That they're all equal.
Equal to what?
Each other.
Equal to what number?
Oh, 60 degrees.
Okay. Now, write an equation that allows me to solve for x.
X equals 20 degrees.
Well, the equation is 3x equals 60.
Yeah, and then you divide it out and stuff.
Okay. And that's what most geometry problems come down to, is being able to write an equation that you have to solve. That's why the first time I saw you, I said that, algebra is just, you do as much algebra as you do geometry when you're doing geometry. And number 12, give me an equation that I can write.
All right. Well, 3x plus 5 equals 35.
5x plus 5?
Yeah.
Okay, solve that.
And then subtract 5 on both sides. And then divide 30 by 5.
Okay. And finally, 13.
9x equals 72. And then divide 72 by 9. Yeah. Should be, 81. Or 8.
Okay, what's the error in the logic that is used in 14?
If
They say angle A is equal to angle C, which agrees with the diagram. Then they say segment AC is congruent to segment BC. Is that true?
the two lines should be equal. So it should be 6, 5, and 5 for the sides.
Okay, but what's wrong with the logic that they give?
They assume that BC is equal to 6.
Well, read the second line. They say that AC is congruent to BC.
Yeah.
That's not true.
Yeah.
In other words, if angle A is equal to angle C, then their opposing sides are congruent. So AB would be congruent to BC.
Okay.
Not AC. In other words, the two sides that I would put a hash mark through are that one and that one. And you're correct, the answer is 5, 5, and 6. But these particular type of problems, they want you to figure out what their error in logic was. And the error in logic is that line right there. That should say AB is congruent to BC. Okay, and 15, let me change my, find the values of x and y for 15.
For 15.
Huh?
That'd be 74 divided by 2 is...
Okay, would you get 74? Do you have a calculator? Do you have a calculator in front of you?
Yeah, 60. It should be 68 actually, but or 78.
Use the calculator, yeah. Now, you know, I'm a huge advocate of doing one-digit subtraction, addition, multiplication, and division in your head. I would rather you not use the calculator to do that. But when you're doing something like this, why not use the calculator? You're subtracting a 3-digit number from a 3-digit number. Okay? And the answer is very important that you get it exactly right. You can't be off by 1. So that's 78. So what's x and what's y?
Both 78.
And we give you more than 180 degrees in that triangle. Plus, do they look 78?
Oh, they'd be 39.
There you go.
So,
in other words, you have to divide that by 2.
Yeah.
That's 39, 39, 102. That adds to 180. Um, 16.
Well, x plus 7 equals 55.
Okay, solve for x.
And then you subtract 5 on both, 7 from both sides.
Okay, so that's x.
Yep, and then x equals 48, so that'd be 48 plus 7 equals 55. So we have 110 on the bottom, so y has to be equal to 70.
Very good. And this is a special kind of isosceles triangle, a right isosceles triangle. And there's only one way to make a right isosceles triangle, and that's if both sides are the same. Now you can draw it differently. In other words, that is also a right isosceles triangle as long as that's the right angle there. Okay? So it can be drawn differently, but an isosceles right triangle is what they're talking about here.
Okay.
Okay. What does that mean about those two angles?
Means that they're equal. So x equals 45 and then y equals 5.
Yeah. Notice really the first thing I can say is that x equals 9y. Okay?
Yeah.
Which doesn't allow me to solve for it.
Because you have 2 variables, right?
Right. I got 2 variables and 1 equation. So if I want to solve for it, I got to come up with another equation. Well, the other equation is that x plus 9y has to equal 90. In other words, the 2 acute angles have to equal 90. Okay? So now, if you just use substitution, and I'm going to substitute that for my x, so I get 9y plus 9y equals 90, 18y equals 90, y equals 5, which makes that angle 45.
Okay.
Since that's the same as that, that's equal 45 also. So x equal 45, y equal 5 is definitely right. I mean, you did it in your head. You did it intuitively, knowing that those had to be equal and they had to be equal to 90 degrees. There's some. That's just the way to do it algebraically.
Okay.
Not that you necessarily have to do that. Have to do it algebraically. There's nothing wrong with doing it the way you did it to come up with the answer quickly like you did. I'm all in favor of that also. Are isosceles triangles always acute triangles?
I know that they're not, but I'm not sure why.
Well, the best way to handle a problem like this is most of the time we look at and we think of that being an isosceles triangle. They're all acute. Okay? But notice that if I make it like this, it's still isosceles, but it's not acute. That's an obtuse angle. And explain the reasoning is if your base angle is less than 45 degrees, then it's going to be an obtuse triangle. In other words, if that's as low as 44, that has to be 44. That's 88. That makes that 92. Anything greater than 90 is going to make it obtuse. So the only thing you need for an isosceles triangle to be obtuse is if your base angles are less than 45 degrees. So in general, how are your grades coming in geometry?
Good. We just had a test over some of our recent stuff, and I got a B on it when the average was below a C, so that's good.
Good for you. Good for you. So your grade is coming up?
Yeah, definitely.
Good. Good. It seems like you're definitely catching on. I don't see any major lapses of understanding when we're doing any of these. Perhaps try to send me a little bit more material. In other words, the moment I looked at this first page when I got it yesterday, I said, well, that doesn't quite look like a half hour's work. Only because these are quite easy. These were much easier than proving congruency. Would you agree?
Yeah.
Yeah, but did you make it through the congruency test? I mean, have you taken a test on that? And that's the one you got to be on?
Yep.
Proving congruent triangles? Good for you. Very good.
Yeah.
Yeah.
With the TCTPC
or it's CPCTC.
Yeah.
Just remember it's every other letter is a C, starting with C. And it's congruent parts, it's corresponding parts of congruent triangles are congruent. The last two C's mean congruent, the first C means corresponding.
Okay.
Okay? But, so what do you got coming up next, do you know?
Well, I know that...
Start anything new today? I would guess similar triangles, but maybe not. They may not go quite that way.
Well, we had to kind of step back for a second and work on proofs for a bit because not a lot of people were catching on those, but...
You know, I think you are done with proofs. I know I've said that before, but congruent triangles is kind of the last place that they ask you to do two-column proofs.
Yeah. Well, even on the test, I wasn't worried about it because I only missed one section of one proof, and we had like 4 to do. So.
Okay.
Yeah.
Good. Yeah. No, the next thing you'll have coming up is chapter 5, I'm guessing, and it's properties of triangles.
Okay.
When you get into properties of triangles, it's not so much proofs anymore. I mean, you might have a proof or two to do the rest of the year, but in general not. It's not to know you don't have to know the theorems. In other words, you have to know what the theorems are, but it's more involved with knowing what it means, not knowing how to do a two-column proof. If you know what I mean. In other words, as long as you know that if you have two parallel lines and a transversal, it's not so important to know alternate exterior, alternate interior. None of those words matter anymore. What's important is you know that 3 is the same as 6, 4 is the same as 5, 2 is acute, it's got to be the same as 7, and 8 is obtuse, it's got to be the same as 1. So it's much more important to know what it means rather than to be able to refer to one of the 4 correct theorems that make
Okay.
all of those true. All right, so I guess we're back on 2 sessions a week, 2 half-hour sessions. Let me just make sure I got the dates right. I got you Tuesday at 4:30, Thursday at 4.
Yep, sounds great.
Talk to you then, Mark. Have a good weekend.
Thank you. You too.
Bye-bye.